Welcome back everyone. This is Runilin and today in another educational video on brilliant.org, as I'm showing here, I'm going to continue with more educational exercise but into a completely different topic. In here advanced math session, I'm going to do some calculus exercise as I'm showing with a pointer here, so I'll click on it right away. Alright, this is calculus. To investigate the central ideas of calculus and learn how to put them to use. Contains 42 lessons with over 300 exercises altogether. So that's tremendously huge progress to walk through. But don't worry, we're only still level 1 at the moment. What is the derivative? So in this exercise is apply. Drop testing is the exercise we're going to walk through today. So I'll click start and I'll click on it. You just wait for a while to get loading it. Alright, there we go. Instantaneous velocity. In testing, phones are dropped over and over to access durability. Let's model a drop test with function h to the variable of t equal minus 5t to the power square plus 1.25, where height in meters, h changes over time in seconds, t. So I'll click play to show how it works. Oh, so I click reset and like play. Height is positive while it falls to 0 as time progress from 0 to a particular time here. I'll play again. This is like kind of a parabolic equation, and I'll click continue here to find out more. The phone's instantaneous velocity at a given time is the rate at which the height changes at that moment. There's a line tangent to the function at any given time. So we need to find if what's the velocity at t equals a. How to find that here? Is it tangent line to a to h to the function of a, or slope the tangent line at a? Let's see. Aha, I think slope the tangent line is here. Yeah, that's correct. So why for reasoning? Velocity is the rate of change at time t equal a, and is therefore the slope of the tangent line at a to the h to the variable of a as required. So I'll click continue here. The phone's velocity at a is the slope of the tangent line at the time, or like h to the first derivative of a. Phone's velocity is the slowest. It's fairly easy, I think here, so check it. That is correct. So why again? At the beginning of the fall, the slope of the tangent line is closest to 0, therefore the velocity is the slowest, as I previously described. Continue. Now, estimate the velocity of the falling foam at t equal 0.3. So simply we need to find that 0.3, so I'll drag it like this. Approximately minus 3.0, so this one is only true. Check. Yup, super correct. So why for reasoning again? As I previously mentioned, the slope of the tangent line at t equal 0.3 is about minus 3. So just drag the point exactly t equals 0.3 to find out its slope of the gradient, where minus sign indicates that the height is decreasing, therefore the phone is falling from the air to the ground, as you just discovered. Alright, so continue. When t equals 0.3, velocity is minus 3 meters per second. Velocity has both speed and a direction, so the phone has a negative velocity because it is falling. What is the fastest phone will fall before it hits the ground? So I think we need to drag like the fastest gradient, so let's check. Around minus 5.0, probably the fastest. Alright, the maximum gradient possible, right? Let's check. Yup, super correct. Why for reasoning it? So here's the explanation. So for the tangent line, when the phone hits the ground is -5. Therefore, the phone is going the fastest right before directly hits the ground, just in a matter of time, with its velocity of -5 meters per second, as you just discovered now. Continue. To summarize it, h to the first derivative of variable t represents the instantaneous velocity at time t as the phone falls. Click on here to find the definition. You see, instantaneous velocity is an object's rate of change of position at a single moment. Kind of calculus mathematics. Right. Next, we'll take the derivative of the derivative to dive deeper into the behavior of functions. Probably we'll discover more about finding derivatives like calculus equations in the very next chapter. Right. That's it, and no more further understanding questions like we did previously. So I'll click finish lesson to conclude. Wow. Level complete. I probably think this exercise is fairly the simplest one compared to the previous exercise because like kind of repeating these graphical exercise, doing these every single day, like calculus mathematics is just basically what I want to create more interesting experience of learning mathematics on brilliant.org. So here's the level 1 is completed in the first place and gained 120 XP this time around. So continue. Boom. Wow. What another incredible achievement so far. 40 days streak in a row. Kind of another extended streak to 40 after completing this exercise on Saturday as here. So continue. No, no, no. Premium users have 20 times longer streaks, but I'm never doing premium at all. Just basic brilliant.org sessions. So remind me later. Alright, there we have it. We've completed the level 1 session of calculus exercise, and this is just the beginning of level 2, how to identify derivatives in more complex exercise in the future. But don't worry about it at all. That's it, all the contents we covered in today's educational video. So thank you very much for watching this, and if you enjoy watching, don't forget to add a like as always and subscribe to my YouTube channel to discover other related videos like this as well. Yes, hopefully this just gives you more interesting calculus, other mathematics, complexity, how to solve general equations, expressions, derivatives in the first place. But I'll come back later to discover these educational contents in the future. Alright, that's it guys, everyone. Take care. I'll see you in the next video. Cheers. Bye.